right, we're going to take a look at bond polarity. Specifically, what we're going to do is try and classify each bond that we see into a different category. And we're going to do this based off of electronegativity. And electronegativity is something that we saw last module, and it describes how strongly an element in a bond attracts the electrons that are being shared in that bond. So the example that I showed you there was of water. And remember, we're only for now talking about the bond between two elements. So even if I'm showing you this particular molecule, I'm only taking a look at this OH bond. And in this OH bond, I showed you earlier in the last module that every line represents 2 electrons. Now, if you're talking about polarity, you are talking about the fact that there are these electrons that are in this bond are hanging out closer to the more electronegative atom. So because oxygen is more electronegative than hydrogen, the 2 electrons that are in this bond are going to be closer to the oxygen. It's more strongly attracted to that oxygen's nucleus. So how do we categorize, or how do we understand this? We have to look at the difference in electronegativity. And remember, on your Nelson periodic table, along with the charges, along with the atomic mass, along with the number of protons, neutrons, electrons, another thing that's included in each element box is the electronegativity value. So if you know the electronegativity value for each element, you can easily find the difference in the electronegativity. So what I would have to do here is take a look at the difference, so electronegativity difference, and this triangle means delta. It's talking about the difference in electronegativity. You have to take the larger value, whichever of the two is larger. So electronegativity 1 minus the lower value of electronegativity. So electronegativity 2. When you find the difference in this, you can use that value to classify each bond. So take a look here. After I find the difference in electronegativity for each bond, if it's less than 0.5, I would consider it to be non-polar covalent. If it is between 0.5 and 1.7, that means it is polar. And then if it's greater than 1.7, we consider to be ionic. Now, what do these terms mean? Say you have a bond that is between 2 atoms of hydrogen and hydrogen. Since they are both the same element, the electrons are shared very equally. So the strength that the hydrogen has to attract the electrons is exactly the same as this hydrogen, which means that the electrons in this bond is going to hang out exactly in the middle. And this is an example of non-polar. So another word that I use to describe non-polar is equal. So instead of saying non-polar covalent, I can, in my brain, say equal sharing. So those two elements are sharing those electrons equally with the same strength. Now, with the example of polar covalent, it's not quite like that. So you've got your hydrogen and your oxygen. I'm not going to draw the lone pairs in there. But the difference between these is that the electrons in the OH bond is hanging out closer to the oxygen. So this shows me, or in my brain, it tells me unequal. So this is still sharing, but it's an unequal sharing of those electrons, and nonpolar is a very equal sharing of electrons. And ionic, so this strength, or the difference in electronegativity, is so different between those elements that it's not even sharing anymore. And if you think back to when we learned about ionic bonding involved one element giving away the electrons to another element. And this sharing is so unequal that it's practically the same as one element giving away the electrons to another element. So let's take a look at an example of a nonpolar covalent bond. So in this case, I have N2. So it's nitrogen bonded with each other. The same thing that I'm going to do is, in order to classify this bond, look at the difference in electronegativity. So En1 minus En2. Now En1 is going to be for this nitrogen, En2 is going to be for this nitrogen. They're both the same element, which means that my difference in electronegativity is going to be 0. So I know that this bond is a non-polar covalent bond. It's very, very equal sharing between the two elements. Now, an example of a polar covalent bond would be HCl. And HCl, if I'm taking a look at the difference in electronegativity, I know that chlorine is more electronegative. I know that from my periodic table. En1 minus En2, 1 being for chlorine and 2 being for hydrogen. So 3.18 is the electronegativity of chlorine minus 2.2, the electronegativity of hydrogen. So 3.18 minus 2.2 will be 0.98. So because 0.98 falls between 0.5 and 1.7, it is considered to be a polar covalent bond. Something else that I want to teach you now is another way that you can show that this is a polar covalent bond. So sometimes when you see a diagram of a polar covalent bond, you might see an arrow, and it's very important where this arrow is facing. If you're drawing this arrow, it's always going to be facing towards the more electronegative element. So in this case, chlorine. So the head of the arrow is facing towards the chlorine. And on the other end, I'm going to put a little cross here. And that cross is supposed to be for positive, right? So the hydrogen is more positive and the chlorine is more negative. So this arrow is what we call a dipole. Right? So it's showing you or telling you that there is an unequal sharing of electrons between these two elements.